Hi guys, okay, this is the famous Pythagoras theorem. So maybe you've come across this theorem before in your life, or heard of it, or heard the name Pythagoras. Pythagoras is a very, very famous Greek mathematician, and perhaps he's most famous for this theorem that he came up with. And the theorem is it is for right angle triangles. Now I've written it over here, guys, in the key points section. The theorem is that for a right angle triangle, has to be right angled, the square of the big side, which is called the hypotenuse, so c squared in this situation, the square of this squared is equal to the sum of the other ones squared. So c squared, this squared, equals a squared plus b squared. In this example, x squared equals 7 squared plus 12 squared. Here, 20 squared equals x squared plus 14 squared. And here, x squared equals 3 squared plus 4 squared. So any right angle triangle is the big one squared is equal to the sum of the other two sides squared. And again, it has to be a right angled triangle. Okay, so there's lots of cool videos, guys, you can watch on YouTube that kind of show you or demonstrate this theorem geometrically or visually or whatever, however you want to say it, or prove it. But I'm just going to go straight into the examples. So first example, find x. So I know x squared is equal to 10 squared plus 7 squared. The big one squared equals, sorry, it's not 10, it's 12. I just made that mistake before, guys, and I had to do the video again. Don't know why I think that was 10. Anyway, 12 squared plus 7 squared. 12 squared is 144. 7 squared is 49. And 144 plus 49 is, there you see my error, 144 plus 49 is 193. And then x, this is x squared, guys. So a lot of people then forget to square root it. Now I always say check when you're, and this is how I recognize my mistake, guys, is you check your answer at the end and you see, does that make sense? So square root of 193 is 13.89. Let's go with 2 decimal places. 13.89 centimeters. Does that make sense? Well, yeah, it should definitely be the biggest, and it shouldn't be too much bigger. So fine, I think that makes sense. Okay, next one. Now, guys, note you can write x squared equals 12 squared plus 7 squared, or 12 squared plus 7 squared equals x squared. It doesn't matter which one you put first. So in this case, because I'm looking for x, I'm actually going to put the x first. So I'm going to do x squared plus 14 squared equals 20 squared. And then I have, and I'll show you another trick, guys, or not a trick, but just something you need to be comfortable with. I'm not actually going to square them. I'm just going to say x squared is 20 squared minus 14 squared. And then I'm going to say x is the square root of 20 squared minus 14 squared. And I can just put this straight into the calculator. So this is the square root of 20 squared minus 14 squared, 2 root 51, or 14.28. 14.28. It's not centimeters or meters, so I'll just leave it. Okay, this last one, guys, there's a reason I added a third example here, even though it looks just like this, even if not easier, but I want to show it to you. So here I have x squared equals 3 squared plus 4 squared. And then I have x squared equals 9 plus 16. And then I have x squared equals 25. And then I have x equals 5. Now I should note, guys, that it's not plus or, because x is a length, it's not plus or minus 5. It has to be the positive 5. Anyway, the reason I showed this example is because this is a famous triangle. It's called the 3-4-5 triangle, or at least I call it the 3-4-5 triangle, because each of these are whole numbers. So when you get a right angled triangle where each side is a whole number, you get what we call a Pythagorean triple. So 3-4-5 is a famous one. Let me show you a few more. 3-4-5 is a famous one. Any multiple of 3-4-5, by the way, guys, is a Pythagorean triple. Let me just try and draw this properly. Okay, like for example, 6, 8, 10 is a Pythagorean triple. 9, 12, 15 is a Pythagorean triple. And there are many others, like another famous one, guys, is another famous one would be, assuming that's a right angle, guys, here, it would be 13, 12, and 5. That's obviously not to scale, guys, but 12 squared is 144, 5 squared is 25, 144 plus 25 is 169, and the square root of 169 is 13. And then any multiple of these are obviously Pythagorean triples. So anyway, there's an infinite number of Pythagorean triples, guys, but it's a very interesting topic to kind of delve into, and it's something you should be aware of because sometimes you might be asked about Pythagorean triples or be able to spot them. Okay, so that's the kind of intro. I want to show you two past paper examples. This theorem, guys, does come up all over the place, and you'll see it in many different topics, including 3 dimensions and cones and trigonometric graphs and all sorts of different areas, and even complex numbers when you go into further mathematics. But just the Pythagoras questions you get in IGCSE on their own, just standalone questions, can be things like this where we mix 2 triangles together. Often, guys, they're mixed in with SOHCAHTOA questions and lots of different topics. So it's not easy to find past paper questions with just Pythagoras theorem on its own, but I do have 2 here for you. Okay, so he says, here's a triangle, gives you all these lengths, work out the length of PQ. So we're trying to find this length, x. Okay, to find this length using Pythagoras, this is obviously a right angle too, we need this length, let's call it y. So maybe now you can see, guys, that we're basically just going to use Pythagoras' theorem twice, one to find y, and then the next to find x using y. So that's just it. Let's do it here. I'm going to say y squared plus 10 squared equals 14 squared. Y squared equals 14 squared minus 10 squared, which is 100. 10 squared is 100. So y squared is equal to the square root of 14 squared is 196 minus 100. That's actually just going to be 96. So y is equal to the square root of 96. Square root 96 is equal to this or this. Now actually, guys, I should show you, or actually I should just leave it like this. It's the square root of 196. Sorry, 196. This is the square root of 96. Now let's leave it like that, because when I square this, I'll just get 96. So now I do it again. I say x squared is equal to 5 squared plus the square root of 96 squared, which is obviously 96. So x squared is equal to 25 plus 96. X is equal to the square root of 25 plus 96, whatever that is, and 25 square root of 25 plus 96. 25 plus 96 is 11. Okay, so that's actually a nice whole number, which tells me I'm probably right, and it's 11 centimeters. Okay, that is question 3, or my first past paper example. My second one, you don't actually see that it's not obviously Pythagoras' question, because Stanley is going to walk from point A here 200 meters east to point B. Okay, so he's going east to point B, and that's 200 meters. He then walks south to point C, due south. Now, guys, you need to know your north, south, east, and west to point C. And then it says work out the length of AC. Okay, so this is 160. That is 200. Let's call this x. Now I can just say, guys, x squared is equal to 200 squared plus 160 squared. X is equal to the square root of this, whatever that is, the square root of 200 squared plus 160 squared. And I get this, 3 significant figures he wants, guys. So it's 256 to 3 significant figures. So that's 256 meters. Okay, that's Pythagoras' theorem, guys. Not too bad in my opinion, but you can find difficult questions and it can come up in all sorts of places. So just make sure you remember, guys, the theorem at least, which is a squared plus b squared equals c squared, where c is the longest side.